What do I mean by this term here? I am having CH3 and I am having OH. This carbon has made 4 sigma bonds, 1, 2, 3, 4. So it is also sp3 hybridized. This oxygen is having 2 sigma bonds, you can see here, 1, 2 and 2 lone pairs are there. So totally this oxygen also needs 4 hybrid orbitals. 1, 2, 3 and 4. So if in case if it is having 4 hybrid orbitals, then the hybridization is sp3. So in methanol, both the carbon and the oxygen are sp3 hybridized orbitals, and that's what they have shown you here. Let us consider phenol here. Oxygen, as we saw in the previous case, just like that, it is sp3 hybridized. But what about the carbon here? Isn't it sp2 hybridized? Correct or not?
Yes, ma'am.
Same way over here. We are talking about ethers here. Each carbon is sp3 hybridized and the oxygen is also sp3 hybridized here. But here you can see the bond angle is different, the bond length is also different. Let us first discuss the bond angle here. The bond angle is 108. Here is 136 and it is 111.7. So I can understand methanol is having the least bond length, bond angle, followed by ether, followed by phenol. Correct?
Yes, ma'am.
Look at the bond angles here. I have methanol with 108.9, followed by phenol with 109 and ether with 111.7. Bond angle is increased. Now what should be the reason here? Look at the terminal one that is present here. Small atom, only hydrogen is there. But here I am having a bulky CH3 group itself. This is also bulky. This is also bulky. So what happens? They need some space. So they both repel with each other. They need some space. Because of this only the bond angle is increased. Understood?
Oh, okay. Yes, ma'am.
And you can see there is a very minute change between them. 108.9 and 109. Again ma'am, here it was CH3OH. Here it is C6H5OH. C6H5 is definitely more bulkier than CH3. So they should have also expected some space. And that's the reason they have gone a little bit away, 109 degree. Okay.
Yes, ma'am.
So the bond angle in alcohol is slightly less than the tetrahedral bond angle. Usually, I said it is sp3 hybridization. sp3 hybridization itself is having 1098 degree 28 minutes. This is its usual bond angle. But what was the bond angle you saw there? Which was 108.9. This itself is less only. Isn't it? Now why it has happened here? Because in alcohol, the repulsion between the unshared electron pairs of oxygen. So when I said this, consider methane, CH4. Its bond angle is very precise, 109 degree 28 minutes, which is also sp3 hybridized. No lone pair at all. But here, you are having 2 lone pair. So what's happening here? This 2 lone pair start repelling each other. Since they are repelling each other, they are trying to move like this. Since it is moving like this, they have to come closer, a little bit closer to avoid this repulsion, isn't it? Do you understand the concept here? These are repelling. Because of that, they want to move a little bit away. Since it is coming, this carbon also tries to go a little bit inside to provide the space for this lone pair. That's the reason there. It is not 109 degree, instead it is 108.9.
Okay, yes, ma'am.
Let us consider phenol here. This is phenol here. Oxygen, though it is an electronegative element, you must have learnt that it is involved in the plus M effect, where the lone pair is shared here, the double bond is shifted here, showing the resonance having double bond O plus EH, and this bond, because it got shifted, it is negative right now. So you can see there is a partial double bond character that is built between carbon and oxygen, isn't it?
Mm-hmm.
So in phenol, the OH group, basically to which it got attached, to sp2 only it got attached, as we discussed. sp2 hybridized carbon in an aromatic ring. The carbon-oxygen bond length 136 picometer in phenol is slightly less than in methanol. Look at the bond length. 142 picometer, this is 136 picometer. Very common question for boards. Why is it happening? Because, ma'am, when I said it was methanol, the bond was only a single bond. But when I said phenol, as I mentioned here, there is a resonance activity that's happening, isn't it? Like this. You can see there is a double bond that has got built. We know very well the bond length of sp3 is greater than sp2 greater than sp hybridization. Here, since it is sp2 between carbon and oxygen, and in methanol it is sp3 with respect to carbon and oxygen, and sp2 should be shorter than sp3. Do you understand this?
Ma'am, I'm finding it kind of difficult to understand.
We are talking about methanol, CH3OH. This is a sigma bond. Sigma bond is corresponding to, only one sigma bond corresponds to sp3 hybridization. I hope you know this. Do you know this first?
Yeah, I got that. Yes, ma'am.
Now when I'm talking about phenol, did you understand this one? What's happening here?
Yeah, there's resonance happening
There's
and
a
there's like
resonance
a
happening.
partial double bond.
So you can see here, there is a partial double bond characteristic that has got developed between carbon and oxygen.
Mm-hmm.
Now the question is asking you, when this bond length is higher when I compare to this bond length. Whose bond length? The bond length between carbon and oxygen. Since it is a double bond character, how a double bond is actually formed? A double bond is basically formed by lateral overlap. That means they have to come to close together to go for the hybridization to happen like this. So because of that only I wrote bond length of sp3 will be more than sp2, more than sp. Now this is sp3, this is sp2. Whose bond length will be more?
sp3.
Yeah, that's the reason why methanol is having higher bond length than phenol.
Ma'am, but how does it affect the angle?
Angle I told you already. Angle
Oh,
is
this is
because
separately
this
for
is for
bond length.
bond length.
Oh, okay. Okay, ma'am. Okay, yes, ma'am. I understood.
So in ethers, we are talking about ethers. There are 4 electron pairs. The 2 bond pairs and the 2 lone pairs of electron and oxygen are arranged approximately in a tetrahedral arrangement. The bond angle is slightly greater than the tetrahedral angle we just now discussed. The bond angle is more than this. Why? Because there are 2 bulky units on the opposite side, so they are repelling each other. They need some space so that the bond angle has increased. That's what they are saying. The bond angle is slightly greater than the tetrahedral angle due to the repulsive interaction between the 2 bulky R groups. Right? And look at the bond length here, it is 141 picometer. It is almost same as to that of your 142 picometer, not much change. Very minute changes there. Okay?
Mm-hmm. Yeah. Yes, ma'am.
We are moving for the preparation of alcohols. Boards have
Oh, ma'am.
tell me.
Ma'am, also between methanol and methoxymethyl, the reason why it's because the bulkiness pushes it like
Yes.
together. Ma'am, but won't it like push it further apart because of repulsion?
The bulkiness pushed it apart, so only your bond angle is increased, right?
Then why does the bond length change?
Not much change. It's just 141 and 142. It's not a big deal here.
Oh, okay. Okay, ma'am.
Okay. Going for the preparation of alcohols from alkenes. So let's look at the mechanism here. First reaction is called acid catalyzed hydration. So I take an alkene, I treat it with water in the presence of acid medium. You can see the reaction is in equilibrium. That means not such a favorable reaction at all. Because carbon-carbon double bond itself is a stronger one here. You are trying to break it. So definitely it will not like it. It has loved its company, but you are trying to break it. So only the reaction is in equilibrium here. So let's understand the mechanism at first. I have water in the presence of H plus. So this oxygen is having lone pair of electron. The lone pair of electron attracted by the H plus is becoming H3O plus. Understood till this?
Yes, ma'am.
Yeah. Now I am having alkene plus H3O plus. So for convenience I am writing like this. Alkene is electron rich because of its double bond. So we will always undergo electrophilic addition reactions. We will always undergo electrophilic addition reactions. Okay, da? So what's going to happen here? We are going to remove this hydrogen as H plus like this, so that this oxygen is retaining its bond pair, so that it can very easily get removed as water. You can see the water removal here, right?
Ma'am, why does it undergo electrophilic addition reaction again?
The double bond is electron rich. So whenever there is an electrophile, that means electron deficient substances is coming, attacking agents are coming.
Okay, ma'am.
It has to go for the addition reaction here. So what's happening here? I have a double bond. The double bond is being attacked by the H plus. The double bond is going to get attached by the H plus here. So the double bond attracts the H plus. It says come on. That means it is having 2 electrons here. The 2 electrons are attracting the H plus. I have 2 carbon here, 1 and 2. So let me assume that the first carbon has taken this H. Now there was a single bond between the carbon that is still existing. Since this bond is being used to attract this H plus, I can understand the carbon now, the second carbon here, it has not made 4 bonds. 1, 2, 3 only it has got. So won't it have positive charge?
Yes, ma'am.
Right? So that's what has happened here. What have we created is a carbonium ion or carbocation. Now carbon, see, carbon carrying positive charge is quite resonance unstabilized. Carbon is the important one for organic chemistry. So the moment you create a carbon positive charge or carbon negative charge, the first work is to somehow satisfy its charge here. So carbon with a positive charge. Now this water left out from this place is having lone pair of electrons. So what it would do? It would come for an attack. The lone pair is attracted towards this positive charge. Now what will I have? CCH, CO. Since the oxygen lost one of its lone pair, will it have a positive charge? Correct?
Yes, ma'am, it will.
Now ma'am, carbon has got satisfied, but I have created a positive charge and an electronegative element. I should definitely remove this because I can't have an electronegative element carrying a positive charge here, isn't it? Now it's happening. Again water is coming. Water is having lone pair of electron. It is going to remove this one of the hydrogen as H plus. One of the hydrogen, once it gets removed as H plus, what will happen? This oxygen will have its bond pair again. So won't it create alcohol? Understood the mechanism, both of you?
Yeah.
Ma'am, can you explain the last one again?
I am having O plus H2. I have to somehow give the lone pair of electron back to oxygen so that the positive charge is relieved. So for comfort, I am writing it in the other way around. OH2, I am writing as one oxygen with hydrogen and another hydrogen is also there. Now water is coming. Water is as lone pair. So it is like a base which will abstract an H plus. So what is it doing? It is abstracting this H plus from this. When the H plus moves out, oxygen is with hydrogen. The H plus moved. Again it's got its lone pair, isn't it? Already a lone pair is there with it. Again the another lone pair is also obtained, correct? So won't it become OH here?
Okay.
What
Okay,
I have
ma'am.
created here is an alcohol. So this is the electrophilic addition reaction mechanism of alkenes.
Ma'am, also in like the nucleophilic attack thing, if it adds H2O, why is it still positive? Is it because of the lone pair in H2O?
Which is positive.
In step 2, why is the O plus positive?
Before the attack of water only it is positive. Once the attack is happening, it lost its positive, its lone pair only.
No, ma'am, in the before thing,
This one.
the step 2. Yeah.
Before the attack of water only it is positive. Now only I am attacking with water. So once it is attacked with water, I get this step.
But in the thing it's given CCO plus H2.
That's what I have also written.
What does the O plus stand for? A lone pair? Why is it positive for that? Because don't we satisfy the positiveness by adding H2 in the
Shows
first
that you
place?
didn't listen to it at all properly. Huh? Listen again. I am having C double bond C. I am having H plus here. This back is attacking the H plus. Having hydrogen. What happened? I have created a positive charge here. Did you understand till this?
Yeah.
Now what's happening? C plus is there. I have to definitely satisfy this positive charge. So water is coming here. Water gives its one of its lone pair to attack this carbon positive. So now that carbon is going to form a bond with the water like this. Why oxygen has got positive? Because oxygen is using its lone pair to satisfy the carbon positive. So oxygen gets positive. Understood?
No, but isn't it already connected? So won't it isn't the positive satisfied by connecting it with C, with carbon?
I don't.
Because it already has another lone pair as well.
I really don't get your question. What is your question? Put your question properly. Your question is
Why is
about
it
the.
still positive when why is there still another positive when there's another lone pair there?
Okay. You are calculating the formal charge. Da. Formal charge is the thing that tells you whether it is positive or negative and all. The number of bonds it has made minus. That means, for example, oxygen comes with how many electrons? 6 electrons. Correct?
Mm-hmm.
So 6
Yeah.
electrons it comes out generally. Let us talk just about water here. What is the formal charge of oxygen? Why there is no charge that is written on just water? When I say water, this is how the water looks like. It comes with 6
Mm-hmm.
electrons. It has made 2 bonds. So minus 2. Minus number of electrons it is having. How many electrons? It has 4 electrons. So it is 0. So only you don't write any charge on this oxygen.
Yes,
Now
ma'am.
I said it has lost its lone pair of electron to quench the positive charge on the carbon. Now there is only one lone pair that is existing on the oxygen. Now calculate the formal charge. It came with 6 electron. How many bonds it has made? 3 bonds. 1,
3.
2, 3. Minus. How many electrons it has got? 2 electrons.
2.
What's your charge?
Oh, like that. Okay. Okay, ma'am.
This is how you find out what is the charge that it carries. Even here, carbon comes with 4 electrons. How many bonds it has made? 3 bonds. Does it have any electron around it? No. So what's your value? Plus 1. That's what you write here.
Okay, ma'am.
Okay. Right. So with this, we'll wind our session for